Hi everyone, welcome to Simplified RSA. We are the guys who makes it looks easy. I am Mr. Maimane and here is another day to simplify some stuff for you to master those exam questions, homework or classwork regarding whatever you may be doing academically. And today we are back to physics again. Here is something I want to point out there. You see, with physics, as much as physics is a whole lot of mathematics, right? But then we get to encounter a lot of fancy words in physics that makes it to seem like it's a bit more difficult than any other form of mathematics. For instance, one thing I want to point out there, whenever they talk about magnitude on physics, magnitude is actually the size of whatever you are measuring. So it's just, it determines a quantity of something. That's what we call it magnitude. Now, previously I did say something regarding vectors and scalars. And I said a scalar is a physical quantity whereby we care only about the magnitude, whereby we care about the measurement only, just the value. Whereas a vector, we care both about the magnitude and the direction. So in most cases, whenever we are dealing with such questions in paper one, would be looking at vectors mostly, because when we talk about forces, when we talk about displacement, when we talk about velocities, we care about where the force is applied to, and we also care about the direction and the magnitude, stuff like that. Now, here I present our question for today. We are looking at 2.1, right? So today I want to talk about the form of vector diagram whereby they call it the head to tail vector diagram. So meaning when you are constructing your vectors, you are joining from head to tail or from tail to head. It's going to make sense as we go through the question. Question 2.1, it reads, the head to tail or tail to head method of representing vector diagram is one of the most scientific methods used to calculate the resultant, meaning either the resultant vector or the resultant force or the resultant velocity, whatsoever we are dealing with at that moment. Now, the question goes further and says, Johnny moved from south to north for 4.5 kilometers, and then he turned from north to west for 3 kilometers. Sharp. And then we are given the compass to show our direction, which one is north, east, south, and west. That one we're normally familiar with that. 2.1.1, we are required to define the term scalar quantity. I just mentioned it right now that scalar quantity, it's a physical quantity whereby we only care about the magnitude only. We don't really care about the direction. So an example would be distance. Distance and displacement is two same concepts, but with distance, I only care about the quantity only, but then with displacement, I care about the direction as well. It will make sense as we go deep and deep with the question. So another thing that I don't worry about is the fact that with definitions, you can prepare yourself before an exam. You can memorize the definition and go write it down as it is. But what worries me is the calculations, which is the reason why I make such videos. And please don't forget to subscribe to all our social media platforms. Follow us on our YouTube channel to get more of such content so that you can be ready for your exams every now and then. Okay, now moving to 2.1.2. We are required to use the scale of 1.5 centimeters to represent 1 kilometers. So 1.5 centimeters is to 1 kilometers to draw the vector diagram and to calculate the resultant displacement of Johnny using the vector diagram. But this time around, we are not really calculating, we are constructing, given in scale, that 1.5 centimeters represent 1 kilometers, meaning I have to use a ruler. If I use a ruler accurately, if I can show the measurements as they are, it has to give me the ideal resultant displacement. Let me show you how it's done. 2.1.2, we are given that our scale is such that 1.5 centimeter must represent 1 kilometer when we draw our vector diagram according to the story of Johnny, right? And here's the story. Johnny, considering that north, east, southwest, Johnny moved probably from south. He moved 4.5 kilometers north. And then when it gets to north, because we are using a head to tail, so this is a vector representing where representing the displacement. So he went north 4.5 kilometers, and then from north, I have to join from the tail because we are using head to tail. So from north, he then went 3 kilometers west. He went 3 kilometers west. And then now, to get my resultant displacement, I construct a vector from the tail of where he began to the head of where the trip ended. So meaning this is my displacement, this is my resultant displacement, which I don't know yet. But given the scale that 1.5 centimeters must represent 1 kilometers, I should use my ruler such that 4.5 kilometers, I must write it in centimeters. So if given the scale that 1.5 centimeter must represent 1 kilometers, I must then ask myself how many centimeters should represent 4.5 kilometers like that. And to get that, it's not as hard. You just have to, you can think of it as cross multiplying. But then if I multiply 1.5 by 4.5, I will get the amount of kilometers required. So therefore, I would get that X should be 6.75 centimeters. So for him, for Jody to travel north was 4.5 kilometers is the same as 6.75 centimeters according to my ruler. Now he then went 3 kilometers west. From north, he went 3 kilometers west. Now, I also have to ask myself again. I also have to ask myself, what is the centimeters scale for 3 kilometers? Again, it's not a haircut. I just go 1.5 again. Now, instead of 4.5, now I'll multiply by 3. 3 times 3 times 1.5 is going to give me 4.5 centimeters, meaning Johnny would have went 3 kilometers, which is proportional to 4.5 centimeters. Now, the final goal that I have to do is just to use a ruler. I just have to use a ruler to construct this, but accurately this time. So I will draw 6.75 centimeters going north, and then from north, I will join from the head because we're using head to tail. I will join from the head and construct 4.5 centimeters going west, and then I will join the resultant displacement and measure how much the resultant displacement is according to the ruler. Let's do that. To scale, I'm going to first construct 6.75 going north. Ideally, this is my 6.75. 6.75 centimeters. And then I will contract 4.5 centimeters for the 3 kilometers. That's 4.5 centimeters. And then to get my resultant displacement, I'm going to join the two and measure the displacement just as it is like the. And to do that, I must join from tail. I must join exactly from tail to head because we're using tail to head method. I must join from the tail of where Johnny began to the head of where the trip ended. Let's do that. up to there. And it gives me roughly 8. It gives me roughly 8.2 centimeters, if I'm to be accurate. It gives me roughly 8.2 centimeters, something like that. So this is my resultant vector, the 8.2 centimeters, using the whole method, the whole description of what happened. So he went north for 4.5 kilometers, which is, according to scale, is similar to 6.75 centimeters. And then he turned west for 3 kilometers, whereby 3 kilometers is proportional to 4.5 centimeters. And then the resultant vector is 8.2 centimeters. That's 3.2.2. I mean, that's 2.1.2. Therefore, 2.1.3, they want us to verify our answer from 2.1.2 now using Pythagoras theorem. As you can see, somehow it shows a 90 degrees angle there. So I'm just going to do this here. 2.1.3. Here is my structure. Given that this is 6.75 centimeters, this is 4.5 centimeters, what would be the value of the resultant vector? I mean, the resultant displacement. So now using Pythagoras to prove that, it's going to be r squared is equals to 4.5 squared plus 6.75 squared, because that's how it works. This is our hypotenuse, this is our adjacent, this is the other side. So r squared is equals to 4.5 squared plus 6.75 squared. And then using a calculator, we get that r squared is equals to 65.81. Therefore, square root of that to get the resultant displacement. Therefore, the resultant displacement is going to be 8.11 centimeters. So, as you can see, it is similar to what I got according to the measurements. Because when I use Pythagoras now from the values, I got 8.11 centimeters. It's not going to be exactly as it is because of the scaling or the use of the thickness of my pen. But more or less, it's 8.11 centimeters, which is similar to 8.2 centimeters. And that's the question that they were asking on 2.1.4. 2.1.4, is there any similarity between the solution in question 2.1.2 and 2.1.3? Say yes or no. Explain your observations. So the answer is yes. As long as your scaling is correct, the answer has to be the same regardless of which method you use, because the same methods lead to the same answer. So that's it with vector diagram, guys. In physics, you will have to draw a lot of vector diagrams and in different forms. For every case when you are given a scale, because like you can construct a 1 kilometer vector on a page, if you understand what I mean. Hence, it's always reduced to a scaling of saying these centimeters are equivalent to the number of kilometers that are given. All the time, as long as your scaling is according to scale, you'll always, what am I saying? As long as your scaling is correct based on your constructions, whether you use whichever method that can lead to the answer or constructing it as you should be, you'll always get the same answer. This is Simplified RSA, where the guys makes it looks easy. Please don't forget to subscribe to our YouTube channel, follow us in all social media platforms, and press the reminder button, because you'll be reminded every time we put out a video like this in all the subjects or all the learning fields that you might be struggling from mathematics, physics, and everything you can think of. That's it for today.